So good morning, everybody. We will go ahead and get going. Thank you for your patience. This is Dennis Sullivan with Mimomax Wireless, and we appreciate everybody's taking some time this morning for an information sharing session that we want to do on replacing leased line technology with considering Mimomax radios. I want to introduce a couple of my teammates on the call. Terry and Dan, would you guys like to make some quick introductions and then we'll get going?
Sure. I'm Terry Oslin. I'm the regional sales manager based out of Rogers, Minnesota, covering the central part of the United States for Mimomax and the top 4 provinces in Canada, north of Minnesota there.
And I'm Dan Broholm. I'm based out of Phoenix, Arizona. I've been with Mimomax for about 3.5 years, working as a support engineer. I just came off a 1.5-year contract working for Salt River Project. That's one of our main utilities out here, working to deploy and support a multi-point network covering the entire Phoenix Valley. I also did some similar work up in Minnesota for Great River Energy, and currently I provide global support for various customers and solutions.
All right, thank you guys. And this is Dennis Sullivan. Thank you again for your patience while we got some of the technical issues worked out. I'm sure many of you have been on more webinars than you can count the past year. I know I sure have, but it's great to see a lot of familiar names on here. So we were going to go ahead and get started here. And for the purposes of simplifying this, to give you some more real estate, we're going to turn off our videos while we're presenting so you have full screen accessibility here. Real quickly, my background is about 20 years in the wireless industry. Prior to coming on board at Mimomax about a year ago, I was with Sierra Wireless for a couple of years, building out a West Coast territory and also Western Canada. And then prior to that, when I spent many years at AT&T and about 16 years at Verizon. And so I've really literally grown up in the wireless space from analog days to 2G to 3G to 4G LTE and now into 5G. And if there's anything that I've seen is that this industry never stops innovating. And I really feel that Mimomax is at the front end of that. And so what we're going to share today is really just an educational session to give you some considerations on how you might look at different technologies that are available to you. There is certainly no shortage of options for you as a utility in order to look at some of this older legacy technology. And so we just want to share some information that will hopefully illuminate to you some options you may not have considered around narrowband radios. We are going to have some Q&A time at the end of this, and we'll open this up for questions from the field. So in the chat panel, post any questions you have up there. We'll address those towards the end. We want to be cognizant of everybody's time. So again, good morning and good afternoon, depending on where you're coming from. And if you're currently already a customer of Mimomax, we thank you for your business. So let me give you a little bit of background with respect to the leased line environment that we're faced with. And my slide is not progressing here. It's been one of those days. Bear with me. There we go. So for those of you who may not be familiar, let me just give a quick overview of Mimomax in case you're not familiar with us. Mimomax was founded in 2007 out in Christchurch, New Zealand. That is where our world headquarters is at. We now have US offices in Phoenix, Arizona, and within the past 9 months have opened up an office in Portland, Oregon, because of the significant growth that we've experienced in the US market. And historically, our key markets have been public safety, utilities, transport, mining, and oil and gas. And obviously, we're going to focus on predominantly the utility space today for this audience, but our primary focus in the utility sector is cost-effective point-to-point and point-to-multipoint narrowband licensed radios that we're going to go into detail here in a moment. So with respect to our founding, we were a company that was spun off from the Tate Communications Group, also located in Christchurch, New Zealand. You may be familiar with them. They have been around since 1969. And so there's a long legacy of deep engineering and manufacturing expertise that we have in tandem with Tate, but we've been a separate company since 2007, and Tate is now a sister company to Tate, to Mimomax Wireless. And you may see a delay on your end. I'm experiencing a little bit of a delay on the advance of the slide, so my apologies with that. The environment around leased lines has really, I think, become full circle the last couple of years as customers are looking at ways to deal with their lease line environment, a lot of older technology that is being, hold on, I'm sorry, gang, don't know what's going on. This was working fine when we tested this out, but my computer does not seem to be cooperating. So let me start this one more time to see if we can advance. There we go. Okay. So just by way of some background, I come from the telco environment, so I know this area quite well, but telco providers are not supporting the lease lines and some of those analog lines in the past the way they historically have. A lot of those costs are going up for utilities. Many of you are telling me that you're seeing increases year over year on your lease line costs as those incumbent local exchange carriers or the local telco that supports you in your region is increasing their costs as a way to motivate and incentivize you to move away from those old technologies into more IP-based circuits, MPLS, fiber, et cetera. And so we're seeing a consistent backlash from customers who are looking at other options but need to have the financial reserves and the capital abilities to do it. On average, we're seeing about $300 per month is what utilities are spending on lease lines, and those costs are only continuing to go up over time as they continue to deal with the changing technology landscape. Gang, I am sorry, I do not know what's going on with my PowerPoint, but you may see the lag on your side. So unreliability continues to be a continued refrain from customers. And I'm hearing about downtime for some customers with their lease lines, some of that older technology just not being supported by the telecom company. They're finding it's really impacting the utility operations. We've seen outages around the country with some of the natural disasters, fires, et cetera. And you folks know better than I do some of the impacts of having those services disrupted and some of your critical infrastructure disrupted at the same time. I know when I was working for Verizon a few years back, we were trying to sell 4G LTE services into utilities, and oftentimes they just wouldn't do business with us because we couldn't offer 5.9 reliability and we couldn't offer SLAs and contract penalties because really candidly at the time the carrier was really set up more as a consumer best effort service, and it wasn't the kind of mission critical communications that you've come to expect. So that was a tall order for me working in that space back then with utilities, and perhaps it's changed. Perhaps the wireless companies are able to give more confirmation of security around those lines, but suffice to say, you know, if you guys are looking at options on where to put your monies for your infrastructure communications costs, it's going to be critically important that you're with somebody that's reliable and continues to support you long term. I may have to switch manually to these slides, so forgive me for that. So what we're going to look at today are considering Mimomax license band radios as a full duplex private communications technology similar to what you've experienced with your current lease line. A couple of differences though is that we're going to be looking at a CapEx model as opposed to OPEX, which a lot of utilities tell me that they're moving to going forward. And certainly over the last year, the pandemic has forced a lot of disruption on utilities, and they're looking at other financial mechanisms to make themselves viable and to get the kind of monies and returns on investment from the PUCs that they need to support. Our technology is capable of meeting T1 standards. Our support, we'll talk more about here in a minute, is 24/7, 365 US-based support with as well overflow in New Zealand. And that's another area that I'm seeing from customers. They're having some challenges with getting support or service level guarantees that are changing with some of those legacy providers. And the support that they're getting when there are outages continues to be a problem. And we're going to talk about the return on investment around Mimomax as a possible alternative to lease lines as well, because that's clearly important for any utility looking to make a change. So I wanted to bring a case study up on a particular situation that I encountered with one of my customers, RACOM. This was last summer. RACOM is a large systems integrator and mobile dealer out of the Iowa market. And they had, the CEO called me while I was on a business trip down in California, said, Dennis, we've lost one of our critical T1 links. It's for one of our public safety responders, and we've lost that link. Can you help us out? We'd like to use your radios to get this link back up. So we scrambled. We're able to get a couple of radios out to RACOM along with appropriate antennas and cabling overnight. And within 2 or 3 days, they had those links up on air with narrowband radios from Mimomax and restoring communications to their customers. That was about a 10-mile non-line of sight link, and they continue to have some storm activity even after the radios were installed. The CEO told me later that that was a problematic T1 link he'd had with his local telecom provider for a couple of years, and said there were often times when they'd have outages when they wouldn't get that service restored for days and sometimes weeks. So that link has continued to stay up, and they've continued to be a growing customer for us, and have replaced that T1 link going forward, and are looking to do more like that. So there's nothing funner for me than be able to support a customer and bring about a solution that really drives some change in their business. Again, this may be a bit of a refresh for those of you who have seen any of our information before, but I wanted to share with you that Mimomax is more than just a radio manufacturer. We have a full suite of services and offerings. Our intent is to be a full service provider to you and make it really simple to do business with. So we have a CNMS GUI based management platform. We try to make that as simple and as intuitive as possible for you to manage your remote radios. In fact, you can plug a GPS antenna into one of our radios and it will populate on the CNMS tool. We also have additional configurations available, so you can add different software features to your radios as needed based on your particular use case. And then down in the lower left-hand corner, this just speaks to some of our support services, US-based support, as well as out in Christchurch around engineering, design, coverage design, path analysis, project management, and really a full suite of services to help support you from the start of the FINIT project all the way through implementation. And then a full complement of radios, antennas, and appropriate gear. And again, I want to reinforce the 24/7 support, because that's critically important. Customers tell us they want quick response, they want to be able to speak to somebody live, and they want their situation handled promptly as far as handling equipment outages or things of that nature. RMAs are processed out of our Phoenix and Portland centers. So we really believe that customer service and a great customer experience are job one. This is kind of our flagship product, the Mimomax Tornado Radio. We're going to go into detail on some of the unique variables of this radio, but this is a full MIMO radio with adaptive modulation up to QAM 256 and a full duplex radio, a very, very spectrally efficient radio. So your cost that you've sunk into investing into spectrum, the ROI on that is important to you and it's important to us, and we want to maximize the use of your spectrum that you have. So we're going to talk more about the capabilities of this radio, but it's a Linux-based platform. It operates at layer 2 and layer 3 in serial and Ethernet, a very space-saving design in a 1RU, so it fits a standard 19-inch rack cabinet. The 2RU is our 1+1 configuration, which is intended for hot standby and for business continuity and redundancy purposes. And in most cases, our radios have internal duplexers, with the exception of VHF that has an external duplexer just because of the size of the duplexer that's required. Very reliable radios that are built to strong fundamentals for the environmental conditions you're going to encounter, rated from -30 Celsius to +70 Celsius. And so we have our radios in extreme environments such as Phoenix, Arizona, in the desert, out of Minnesota in the snow and the mountain tops, etc., and around the world. Very reliable radios. That's going to be critically important for you, as we'll see here on some of these use cases that we're going to share. But quality of service is supported with very low latency and resilient paths along long links. We have some links that are currently up in excess of 60 miles, and that's even over bodies of water. So we have chosen to operate in the licensed spectrum bands, and so we operate, as you can see on the slide here, in VHF, 400 megahertz, 700 megahertz, 800 and 900 megahertz bands, and we're always consulting with customers to see other bands that could be supported, but right now we're in sub 1 gigahertz where we specialize. So let's talk a little bit about some of the capacity advantages of MIMO. This is a technology you're seeing quite frequently now in 4G and 5G systems, and even in some Wi-Fi systems as well. And this allows you to double your throughput over a single antenna or transmitter or a traditional SISO system, which you'll see in some of our competitors' radios. But something that we do that's a little bit different is we have full duplex and orthogonal polarization built into our radios. So we're able to transmit over both the vertical and horizontal polarization, and that can take your 2x data throughput and increase it 4 to 5 times over competitive radios. So that's critically important. I want to just give a quick primer here on modulation. I'm not an engineer, so I'm going to touch lightly on this topic. But just quickly, just to give you kind of a visual, this is a constellation diagram that helps to kind of showcase what's going on within the radio. We started out with FSK modulation, and now you see QPSK, 16 QAM and 64 QAM, pretty common throughout the industry. But what you're seeing here is that each dot is a symbol, and each symbol represents a number of bits. So with FSK, we're able to transmit 1 bit per dot. QPSK is 2 bits per dot, and 64 QAM has 64 bits per dot. But when you extend that out to QAM 256, that's where the magic happens. And that's really the kind of the secret sauce of what Mimomax does, is that we're utilizing full MIMO. And so this can exponentially grow with the ability to push more data through these narrowband channels and drive up your efficiencies. And in fact, we get 16 bits per hertz in our radios, which is critically important as it relates to maximizing the spectral efficiency you have available to you and leveraging the available bandwidth as well. Something you may also be familiar with is full duplex technology. You know, time division duplex has been out there for quite some time, but is not very good for IP traffic. And so we leverage this as well to maximize the full duplex MIMO. And the end result for you and the outcome is a very small buffer, very low latency, perfect for IP traffic, and this allows us to get 640 kilobits per second in both directions of the link. So it allows you for high throughput, very high spectral efficiency. In fact, these radios are 100% efficient for UDP traffic and 99% efficient for TCP traffic. So again, part of our secret sauce, don't tell anybody, it's a secret. Relative to capacity, this just gives you an example of some of the flexibility that we have in our radios. And again, our radios are custom built to you as a utility, to your use case, to your particular scenario, based on what your requirements are. We engineer to 5 nines typically on our path analyses, but this gives you an example of some of the raw data throughput you can expect in a tornado radio. Our typical scenario might be a 16 QAM and 25 kilohertz channel, so that would give you 320 kilobits of raw data. But because of some overhead for forward error collection, you're going to get about 7/8 of that throughput. So about 1/8 of the data is going to be attributed to forward error correction in the radios. So let's talk about latency, because that's something that's always top of mind for utilities. The typical latency that we see in a point-to-point environment is sub 10 milliseconds. Again, that'll be based to some extent on the channel bandwidth and modulation that you're utilizing. Typical latency in a point-to-multi-point network that we operate would be 25 to 35 milliseconds in a 50 kilohertz channel. And as you'll see here momentarily, we have deep expertise in both. So obviously in utilities, you guys know this far better than I do. This is your world, but latency is job one. And certainly in the area of critical communications and mission critical grid infrastructure, being able to engineer these links so that they are reliable and stay up to 5 nines capabilities is what we do day in and day out. We want to make sure that we can not only maintain low latency and jitter, but have these be very resilient communication paths. And so this speaks to a little bit of the one-way latency that you'll see in a typical point-to-point configuration. And obviously, as you increase modulation, you'll decrease the latency. But even at QPSK and 12.5 kilohertz, 35 milliseconds one-way point-to-point, pretty significant around low latency. Teleprotection is another area. We're seeing a lot of interest from utilities again, where leased lines are in use currently, and teleprotection is critically important. Folks in the protection groups know this far better than I do, but you know, teleprotection relates to two main functions, and that is isolating the faulted sections of your system, while at the same time maintaining power delivery and capability in the rest of the system to protect quickly against disruptions or significant catastrophic failures. And so these protective relays must trip and respond almost near real time and have ultra low latency to support that. And as I said earlier, we have an optimized variant protection software protocol that goes into our radios for teleprotection so that that traffic is prioritized. It cannot be interrupted with any other IP traffic, and this is what allows us to get down to near real-time communications within a teleprotection link. This chart here is a bit of an eye chart, but it really just kind of illustrates that we are attempting to cover all the bases for you as a utility when it relates to latency and the different hardware configurations you may have. We support all of these different connectors from X21s to RS422s, and the appropriate equipment can go in with our radios and be plug and play to be able to work in a teleprotection scenario. So just to give you an example of a current customer, Puget Sound Energy had done some testing on the bench before they decided to deploy our radios out in the field. So they had to set up a couple of Schweitzer line protection relays in their bench lab, operating in the upper 700 band frequency that they own, and they measured that at 17 seconds millisecond round trip delay. When they inserted a couple of Mimomax radios back to back and ran it at 16, 64, and 256 QAM, they realized that the radios only added an additional 1 to 4 milliseconds of latency. So they were pretty impressed by that, and so much so that they reported out these readings at one of their breakouts at a UTC conference. So that just reinforced for us that what we're seeing, and again, we're a very conservative company. We really try to under promise and over deliver, and so our data sheets really rely on that philosophy to keep consistent with it and outperform. So let's talk a little bit about other use cases where you might see a lease line replacement possibility. LMR backhaul is another area where Mimomax radios are getting adopted quite a bit, and this is really speaking to somewhat of the public safety environment as well as some utilities that might have some LMR, but we're the backhaul component for those networks. And again, because of the quality of service and the compression techniques that we have with voice technologies, we're able to maintain a high level of service quality and maintain that criticality in plug and play situations where LMR backhaul is necessary. This again is just another example of kind of demonstrating what that looks like in practical terms. So in a typical 25 kilohertz network at 64 QAM, you're looking at 8 trunk channels of P25 traffic with 79 kilobits of residual bandwidth left over. So this is important to understand because it just allows you to have some flexibility in how you might use tornado radios and different environments for different situations. And even in the case of analog, we're able to get up to 6 channels of analog audio as well in those kinds of older environments. SCADA is another one that's obviously top of mind for utilities, and where we see probably the predominant usage of lease lines and T1s throughout the industry. We speak with customers all over, including Canada, about some of their requirements around critical communications capabilities and what's available to them. I don't need to tell you guys how important it is to have command and control over SCADA and those substations and those endpoints out to your customers. These radios are designed to help support these types of capabilities for you and your customers. So I want to touch briefly on the multi-point configurations. We've talked up to this point about point-to-point, but now I want to speak to multi-point configurations, and this really has to do more with the larger scale field area networks that Mimomax has been involved in. What you're seeing here is utilities that are typically larger in scope will purchase spectrum amongst a broad area and be able to have a robust and reliable scalable network that can be both a tier 1 and a tier 2 capability. So tier 1 being, high capacity, low latency network that supports those high value assets on your grid, the cap banks, the reclosers, et cetera, and then a tier 2 network extending out to the endpoints on your network. Case in point, and where we have an awful lot of expertise, is in the upper 700 band megahertz spectrum, is a large deployment that we have done for SRP, one of the largest utilities down in Arizona. And this is an environment where pretty much covers the entire state of Arizona. It's kind of been created based on cellular technology in that it was designed kind of off of some of the cellularization that you've seen around the industry. And we have, in that particular customer environment, we have 50 base stations with tri-sectored antennas, and obviously required a significant amount of coverage around there to be able to support it. It's in a very extreme environment with temperature, and our equipment is installed both in racks as well as externally. We don't require any additional fans or anything like that, and those radios continue to perform very well across an environment that's very demanding and a dynamic environment, I might add, as well. This slide speaks to that dynamic nature of 700 megahertz spectrum. We have other deployments in Minnesota. In fact, we're doing one right now in the Portland, Oregon market for one of their largest utilities. So we have quite a bit of experience and expertise, and like to share these best practices with customers that are looking at potentially expanding into 700 megahertz or are looking at building out affiliate area networks and leveraging the expertise that we have in this band. We're able to channelize the spectrum in a way that makes sense for you as a customer, and this just kind of gives you a visual representation of what that may look like as a way to segment traffic based on your utility, your usage cases, and where you need traffic to go. And really, in the case of SRP, as I understand it, it's a very dynamic environment, and the customer's looking at that changing and adapting as time goes on based on the needs of your business, based on the demand response you need to support your customers, especially with online renewables coming online and distribution automation increasing, the flexibility that you have in managing a field area network and then critical comms that support it are really important. So we're going to talk quickly about ROI, and then we'll wrap up with a couple of case studies. But we're going to look at one scenario of a typical customer that has 10 lease lines and wants to consider swapping those out with Mimomax with 10 radios. For larger deployments, for larger utilities that have a larger scale of the geography that you cover, it might make more sense to look at a point to multi-point network, and that will obviously change the ROI model. But to give you an example of what this may look like, we ran a typical scenario of 10 lease lines at $300 per month and an example of your payback with Mimomax. Again, as we mentioned earlier, this is going more from your OPEX model that you're in today with lease lines to a CapEx model going forward. So you have the ability to make that investment upfront with equipment. And a typical scenario, you're looking at a break even of about 2.2 to 2.5 years on average. This is really where the ROI starts to play out and moves more from that OPEX to CapEx that we talked about earlier. So we have some numbers that we can share with you later as well, but a typical kit would look something like this. On average, a leased line replacement kit like this runs anywhere between about $4,500 and $11,000 US. It will vary depending on the configuration that you have, the custom build that we have on your radios, as well as some of the different feature sets that are available, in addition to some of the hardware and other components that you may need. But a typical kit, like you would see here, would be a couple of Tornado radios, appropriate panel or Yagi antennas, and then the appropriate connectors, interfaces, hardware components for teleprotection that may be necessary, etc., including a 4-wire audio box or some of these other interfaces that might be necessary in your particular environment. Speaking of that, this is the 4-wire audio box that some of our simulcast customers use, as well as some of those analog customers as well, to manage that traffic. And again, maintain the high performance and the spectral efficiency of the spectrum you have access to. So just to kind of wrap up here with a couple more case studies, I mentioned Puget Sound Energy here in the Seattle area, the Pacific Northwest. They had a couple of links that they were needing some assistance with. Fiber and microwave were not an option for them. So they reached out to us and said they needed a link, about a 9-mile link. This was a backhaul system in 900 megahertz for a Tate MPT IP network. A very challenging topography here, lots of dense tree cover, icing in the winter and snow accumulation, etc., due to our temperature extremes up high up altitude. So this is a case where we had a 9-mile path and a 20-mile path, both running at full speed with panel antennas in that environment. Those radios continue to operate very effectively for their SCADA and some other operations that they have, as well as voice. We've mentioned SRP. I just want to call attention to it because we do have a pretty extensive case study on our website at mimomax.com, and you're happy to download that. There's a lot of other information up there as well on other use cases across other verticals and other scenarios that we haven't talked about. But this network is continuing to grow and be dynamic, as I mentioned earlier. It currently covers about a 13,000 square mile area, including their watersheds, reservoirs, and they're looking to constantly update that as necessary. We're initially continuing to deploy a tier 2 network with some of our other radios out to their endpoints closer to their consumers. And then the last one that is really one that's close to home, both literally and figuratively, is an earthquake, 6.3 earthquake that happened in our head office city of Christchurch, New Zealand, just over 10 years ago. I can't believe it's been 10 years ago. But that was a significant event where Orion, their local utility, had our radios installed in their network. They lost a lot of local communications, cellular networks were congested, landlines were down, fiber was split, significant damage to the community. And through all of that, the Mimomax radios and antennas continued to perform. Even when some of the towers were out of alignment, azimuths disrupted, our radios continued to perform, and they have since then continued to expand their network with more tornado radios. So for me, this is a very personal thing because I have friends that live out in Christchurch, and the ability to have your communications infrastructure up or down with minimal downtime, if that should ever happen, is critically important. And so it's important, I think, to partner with somebody who's got experience when the worst kind of things happen. In fact, we have a number of customers right now deploying our radios for early earthquake warning sensors along the West Coast, because we're also very prone to earthquake activity throughout the Northwest and throughout California and down the Western seaboard. So this is something that customers are looking very seriously at because of the performance of our radios and the ability to work in these kinds of demanding conditions. I also want to share, before we wrap up and open it up to Q&A, we do have a North American-based sales team. Terry is on the call as well today. Keith is our East Coast contact, and we also support the geography in Western, Central, and Eastern Canada as well for our friends up north. So with that, Adi, I'm going to kind of open it up here, and I think we're going to open up the bridge for the Q&A. Hopefully that made some sense, gang, and we look forward to sharing some more information with you here. And let's hope that we can get this to work properly this time.
To Dan and Terry, if you would like to turn on your webcam for the Q&A sessions, that'll be great. And thanks everyone who's attending. Adi here, so I'll be moderating the Q&A sessions through all of the questions that you have been put on the panel. It's really great to see that we got quite a lot of engagement. So well, let me just start with the first questions that came up through for quite a while. And I think this questions is more Dan for you. In terms of the performance measurement, Dennis, if you could go back to the table that that showcased the sensitivity and QAM modulation.
Too many slides.
Yep.
This one, okay.
Yep. No, the sensitivity. Not that one. That's the latency. Go back again, back again, back again. I don't think that's the one, but really the question is then, are your performance measurement, the sensitivity, taken before or after the duplexer? Yes, that one.
So our performance figures are measured through the Tornado's internal bandpass filter, whereas other products may not take the loss in transmit power or sensitivity inherent in adding an external duplexer to the system. So pretty much what you see is what you get out of our product.
Great, thanks. It's good to know that. The next questions, I feel like this is sort of questions for Terry, since you have encountered a lot of these questions in regards with capacities. If you want to achieve the bandwidth figures that's shown in the 256 QAM right there, do you need a higher signal level, or is a moderate signal level is fine? Sorry, Terry, I think you're on mute.
Oh, can you hear me now? I'm sorry. It depends. It's all going to be based upon really a path profile. And what I tell all my customers is, as long as you can get me the lats and longs or the coordinates, the antenna height, you know, what frequency you're using, how many kilohertz the channels are going to be, We can, and what your interface is going to be. Is it going to be serial or Ethernet? Because every radio comes with 2 serial ports and 2 Ethernet ports. Or do you need some like a 4-wire interface, or we're going to be hooking up to fiber, whatever. You get us that information, we can do a path profile, and then based upon that, we'll come back with, you know, what your modulation rate is going to be, and you know what your latency you can expect, and it all kind of gears around that. So I throw that out to every one of my customers is, you know, get me that information and we will be more than happy to do a high level path profile and get you the information to see if it is a viable solution for what you're trying to accomplish.
Great, thank you. Just to follow up with that questions as well, there's another questions that talking about modulation rate and latency. And we know how important latency is, especially in utility sector. How are the latency rates impacted by the modulations that you use?
Okay, well, obviously the higher the modulation, the lower the latency is going to be. Once again, it gets down to a path profile. So if you can run at 256 QAM to get your 5 nines reliability, if that's what you're trying to achieve, you know, we're typically going to see latency less than 4 milliseconds, which, you know, is very achievable. But once again, it's going to depend upon the link and what you're trying to achieve. But once again, you get us that information, we'll be able to determine that for you.
That's right. So it does really depends on the path profile itself as well.
Correct.
Yep. Cool. Thanks. The next questions come through in regards with what if we were running a serial traffic alongside with IP traffic through one of our leased line, how will this traffic be split in your radios? I guess that's the questions for you then.
Well, that's dependent on the bandwidth and modulation that the link's running on. For example, if we take the 64 kilobits per second required for serial teleprotection data running over a 25 kilohertz channel with a 16 QAM modulation, that would only leave us with about 50% of residual bandwidth for IP traffic. Whereas if we increase that to a 50 kilohertz channel running 256 QAM, we'd have roughly 450 kilobits of available bandwidth for that IP traffic. So it just really depends on the link, you know, the modulation that we're running.
Right, right. And if somehow the link is quite long, would the latency and the bandwidth be impacted as well?
Not so much the bandwidth itself. There is some inherent issues, or I guess I should say that there's a little impact on the data, but there might be a little bit of impact on latency. A little bit of impact on data throughput is basically just would be due to standard propagation loss due to the distance of the link. We do have options for reducing modulation, and in doing so, we can increase the sensitivity margin of the RF and maintain the requirements needed for that solution.
All right, cool. Thanks for that. Dennis, I guess this is a questions for you. We do have quite an interest in the linking kit that you presented earlier. Questions was how long is the linking kit will be available, and do you have any price range in mind on that?
Yeah, that will be our linking kit bundle going forward. It ranges, as I mentioned earlier, between 4,500 and about 11,000 or so, depending on the configuration of the radio, the antennas, different connectors, 4-wire audio box. There's a number of different components that would determine what that total bundle price will be, but that's certainly something we can consult with on a case-by-case basis. And in fact, I think towards the end here, you'll have a document that customers can download as more information from coming out of this webinar. Is that right, Adi?
Yep, that's right. Now, I guess this is another questions for you as well, Dennis, to elaborate in terms of the case study that you present with RACOM in terms of non-line of sight. How will the radio cope with non-line of sight applications?
It really comes down to the path study that Dan was talking about earlier, and also Terry. Our radios don't require line of sight. We have many links that are up that are non-line of sight. It's all going to be based on the path, the link, the modulation, and we do the analysis on that up front, so we know exactly what we're getting involved with. Customers typically will send us KMZ files to start some of our initial indicative path studies, and then we can do deeper analysis beyond that. And we oftentimes will utilize path loss or cell plan or some of those more extensive paid tools as a way to really validate and vet this out before we ever get any radios on the air or sell radios. So bottom line is we'll make sure it's going to work in your environment. If it's not, we're going to speak up and tell you that it won't. We'll give you options on what to consider if it's not a Mimomax solution. And that's the integrity that we have as an organization, is we're only going to tell you what's going to work with our radios in our environment. If it doesn't work, we'll let you know that and what your options might be beyond Mimomax, because not everything is a perfect fit, and we recognize that. So where we're good, we're really good, but where we're not, we're going to tell you it's not a good fit for us.
Awesome, good answer. Terry, the next questions that comes up, I know that you've your customer have been asking a lot of this as well, so I thought that this might be a good questions for you. Can the radios be mounted outdoor, or does it has to be mounted indoor?
Yeah, the radios are actually, you know, could be mounted outside by themselves, which, being in Minnesota, I wouldn't recommend that, I guess. Anybody living here probably wouldn't deal with that, but it is capable. I mean, we do have a little hood we could put over it, so you could mount it on a pole if need be. Typically, what I'm seeing is you're going to mount it in a cabinet, you know, which we have wall mount brackets, we have DIN rail mounts. Pretty much any way you want to mount a radio, we can do it. Or if it's if you're in a, you know, a shack, you can put it in a one rack RU rack mount unit. If it's a 1+1, it fits in a 2 rack mount unit. But to answer the question, yeah, it could be mounted outside on its own with a little hood over it if you wanted to roll the dice on that. But it'll hold up to it and stuff. But in Minnesota, I'd rather have it in some sort of an enclosure. And I think most of my customers would agree with that.
Yeah, well, considering the extreme weathers that we have up there, yeah, probably that's a better idea. But yeah, anyway, I'm still seeing quite a lot of engagement and questions, which is really, really great from this webinar. But considering the timing that we have now, which we're already hitting 47s, I guess what we're going to do then is I think we're going to need to follow up all of the individual questions individually through you guys through email. So what we'll do is we'll send out a follow-up answers together with some more information on our leased line bundles and the recording to the webinar as well.
Very well, and I just want to wrap up with a couple of things here before we drop. I also wanted to mention Spectrum being a topic that we brought up earlier. We do work with the Spectrum brokers around North America. So if you have a utility that are interested in buying more Spectrum, or maybe you're just newly exposed to this and was not aware of it, we can help facilitate those conversations, help you build the ROI modeling to help support the business case around Spectrum. And so we can help provide support and consult with you around that. And then lastly, I wanted to mention, and we will, as Adi said, we'll send out this recording once it's all done to the audience. But I want to let you know that for those of you that are on the West Coast, I will be attending the UTC Technology Forum, regions 8, 9, and 10 next month in Reno. I can't believe I'd say this, but I'm actually excited to go to a trade show because it's been a year since I've seen many of you. And I'm hoping that if some of you that are on the West Coast that are in those regions that might attend, and that we'll have a chance to meet. In fact, you'll know it's me because I'll be wearing one of these things. And I figure, hey, if you can't have some fun while you're at work, then why bother? So all kidding aside, thank you very much for your time today. We really appreciate your input. Looking forward to your questions and your feedback, and really ideas for additional content going forward. We want to support you and support this industry. And so thank you again for your time. We appreciate it. Have a wonderful day and a great weekend. Thank you.
Thanks, everyone.
Thanks, everyone.
Feel free to download the leased line brochures of the day. Thank you.